So this problem here has several scenarios that uses the various aspects of the time value of money. In the previous problems we've looked at just the present value, but now in the first one here we're looking at Meredith just hit the jackpot in Las Vegas and won $25,000. So if she invests it now at 12% interest rate, how much will it be worth in 20 years? So now we need to use our future value tables to come up with the factor. So we're looking for interest rate of 12% and n equals 20 for 20 years. So the factor you're going to multiply it by is 9.646. So if she invests the money in 20 years' time, that $25,000 will be worth $241,150. And of course, if you use it, do the calculation with your calculators, you'll end up with a slightly different number, but both are equally correct, of course. The second scenario is saying we would like to have $2 million saved by the time he reaches, or time he retires in 40 years. So if you want $2 million in the bank in 40 years' time, how much would you need to invest now, assuming you had an interest rate of 10%? So here again, you're going to look up your present value factor. Here it's present value. Before it was future. So now we want to, whenever you're calculating how much something is worth now, it's present value, whereas if you're looking at how much is this worth in the future, you're using future value tables. So 2 million, and we're looking interest rate 10 and n equals 40. So 2 million times 0.022 is the factor you're taking from the table, 44,000. So if you put 44,000 invested now in, and assuming you can get an interest rate of 10% for 40 years, you'll have $2 million in 40 years. The third scenario is asking us to assume that Stephanie accumulates savings if she of $1 million by the time she retires. If she invests these savings at 8%, how much money will she be able to withdraw at the end of the year, of each year for 20 years? So now when you're looking at an annual amount, that's going to be an annuity rather than a lump sum amount. So if it's an annuity, you're going to have to look up your annuity present value tables. So the annuity, so if you have $1 million is what you want now, and you're trying to solve for the annuity, trying to solve for the amount. So you have, your annuity here is really, think of this as X. This is what you're trying to solve for. So what you're doing here is you're going to take your both sides of your equation and divide by 9.818. And you're dividing this by 9.818, and that's how you come up with your 100,000. So 101,853. So that is that's the amount of money she will be able to withdraw at the end of the year for 20 years and still not run out of money. The fourth scenario is looking at someone who wants to invest $2,000 at the end of the year for the next 7 years. So if you assume an interest rate of 14%, how much money will that be worth? So if you invest $2,000 a year for 7 years, assuming you can earn 14% interest rate on that, in 7 years' time, that'll be worth $21,460. Scenario number 5 is assuming an interest rate of 6%. How much would you have to invest now to be able to withdraw $10,000 at the end of each year for the next 9 years? So if, again, because it's an annual amount, you're looking at your annuity tables. So you're looking at 6% for 9 years. That's to come up to locate this factor. So you're multiplying that factor by your 10,000, so it gives you 68,000. So basically, 68,020. So basically, if you want to be able to withdraw 10,000 a year for the next 9 years, you need to have 68,000 and change invested now in order to have enough money to make those annual withdrawals. And the final one that we're looking at here is Devin is considering in number 6 a capital investment that costs $485,000 and will provide the net cash inflows listed below. So that's in the table there. So they're using a hurdle rate of 12%, or an interest rate of 12%. So. And you're expecting, of course, different cash outflows. So here, the present value is going to be equal to 12, but you're going to have different factors because for each of the years, you're getting a different cash flow, 300,000, 200, and 100. So you're going to have, for the first one is 12% n equals 1, 12% n equals 2, and 12% n equals 3 to locate these factors. So the present value of that is $998,500. The investment was $485,000. So this leaves you with a positive net present value of $13,500. So it would be beneficial to make the investment because the net present value is positive. And number 7, our last scenario is, what is the internal rate of return? So the internal rate of return is the interest rate at which the net present value is 0. So what we're looking at here is you are trying to identify the present value factor at 14% for each of the years. The total present value is 484 less your investment, so it comes out to be a negative NPV of 600. So if you know that what you're trying to do is find out at what interest rate will this 600, rather than being 600, that will be 0. So that's your internal rate of return. So we know it's going to be somewhat less than 14%. And if you had done this calculation using your calculator, you would find that it's 13.93. So internal rate of return is the point at which your NPV equals 0. And that concludes problem 12-58.